Okay. So again, good morning to you all. So we are here to conduct a complete seminar, complete theory seminar on the lesson part, measuring instruments, right? Measuring instruments. Before deep dive into the physics topics, measuring instruments lesson, I have to say some guidelines or the some kind of instructions to you how you want to join for an online session like this, right? Online seminar. And also, meanwhile, if there are some friends of you who wish to join, also let them know. Join quickly to the session, right? Okay. Here's the thing. Uh, the first thing is this is an online seminar, right? This is an online seminar. Uh, I did the same online seminar for single medium students past a week or one day. There we will have to do the seminar uh, for more than 6 hours, right? More than 6 hours. So today's session also will be go for more than 6 hours. So then, how you how you want to behave in such kind of online seminar? That's my first point. So since this is online, I can't see you, right? I can't hear you until you turn on your mic and speak something. Until you put something on into your chat. Right? So always use the chat box and also you can unmute, right? Always use the chat box and also you can unmute yourself at any time because then only the communication is established between me and you. So if the communication has not well established between me and you, then you can't get the 100% efficiency of this seminar. Not only this, for any kind of online seminar. So always use the chat box and also you can unmute yourself and ask any questions. Or you can say, if I'm going to erase the board, you can just unmute yourself and say, please stop for a while. I'm just writing now. I still writing. So don't erase. Like you can say anything. Otherwise, the main thing is I can't see you. I also can't uh, understand that you understood the thing well or not. So the only way to build this communication part is use the chat box and use the microphone, right? This is that is essential, right? Also within the seminar, uh, I will explain the parts in English and Sinhala as well, right? So you can ask or put them into the chat box in both languages, English and Sinhala. But I can understand Tamil. You can use English or Sinhala, both languages, to communicate with me. There's no any issue. Uh, and also, there's an interesting fact here that normally within the online seminars, I always tell to the students that if you got understood, if you got understand, just put understood into the chat box. If you have finished writing, just put done. If you got yes, put yes, like those kind of things. I'm always telling to you within the seminar. Then you have to open chat box and react with me, engage with me. So for in an online seminar, engage is the key of engage is the key of grabbing the things from me. You have to engage with me always. Uh, the reason for getting you engaged is like this is online seminar. You can also sit on your bed and keep your laptop or phone in one hand and watch the seminar. This is totally useless. If you want to get the complete use, you have to go for a table and keep your laptop and take a chair and sit down there and work properly as normally you are in a class, right? Then only you can get the optimum usage of this seminar, any kind of online seminar. Then you are getting few inputs from me. What are the inputs you are getting? Uh, you are looking at this seminar. You are looking at the whiteboard and how I am working on these parts. So you are getting input from your eyes. You are hearing my voice. You are hearing the concepts. So you are getting input from your ears, right? Uh, okay, sure. You are getting the input from your ears also. Then, meanwhile, getting those two inputs, if you are chatting on the chat box, like you are working your fingers to put some any kind of words that I am saying, putting yes, putting done, no, anything, then your brain starts to think that you are looking something, you are hearing the same thing, and also you are engaging with that activity with your hands. Then your brain thinks that this should be a kind of important thing to you. Then only brain starts to memorize these concepts, right? Because you can't memorize anything by forcing, right? The brain is the one who is responsible for memorizing all the parts. You can't do it. The only part who can do it is your brain. So the thing you can do is tell your brain this is the important part. You have to memorize it for 2.5 years, right? You have to memorize the things you are learning today for another 2 years. So the thing you can only do is you can tell your brain that these parts are very important. You have to memorize this. So how to tell it? The way to tell your brain is always engage with me, and the brain automatically will know that this is an important kind of thing, right? This is an important kind of thing. Uh, there are some chats. Okay, sure. There are some students who want to go for the mosque at 11. Yeah, you can go and come. Right. That is the first thing. And also, I request you to rename yourself with your first name and last name. Like, for example, my name is Thusith Herath. So, I have renamed it as Thusith Herath. Right. Uh, you also need to rename yourself because uh, my suggestion is don't take this as a kind of a big class or some kind of say that kind of thing. Just just be relaxed and sit on your chair and just do some workouts. That's enough, right? So for that, please rename yourself with your first name and last name. Then I can call you here, Santosh, here, Tisar, like that. So rename yourself with first name and the last name. And also, you can ask any questions in the chat at any time. And also, if you want to say something or ask something, you can raise your hand. Or also, you can unmute yourself and excuse me, sir. Is there this kind of a problem I have? How to solve it? Anything, right? Again, the key is engage. You have to always engage with me, right? And also within the seminar, we have uh, content to cover, and it will nearly go for 6 hours, more than 6 hours. We will not do the class continuously for 6 hours. We will give you some breaks within the seminar, right? So don't worry. Like by 2 hour intervals, we will give you some breaks. Okay, let's move to the seminar, measuring instruments. Before that, please put on your chat that do you have a printed copy or soft copy? Just put in your chat, printed copy or soft copy. Quickly put. Right. Please put on the everyone's chat, right? Then it's easy to go through your tools. Printed, printed, soft copy, soft copy, soft, soft. Yeah, right. English medium students are brilliant, right? You are engaging with me very well. I like it. Nice. Okay. Many of you have soft copies, right? So the ones who have the hard copies, you can complete it in the tute itself, right? The ones who have soft copies, please keep a set of A4 or foolscap kind of any other sheets with you. While looking at the tute, you have to write the things I am saying to write in the in your prepared sheets. So you don't want to write the note because the note is in the tute. Right? The note is in the tute. You don't want to write the complete note. The complete a comprehensive note is there. You have to write some parts. So when you are writing those parts, just put the page number or something and write the relevant part, right? And after the seminar, end of the seminar, today or tomorrow, you can get a printed copy and again do the workouts from the tutorial. Then you will memorize the things very effectively because you have for the first time you have been in the seminar and listened to me and you have done workouts with me in your kind of any prepared sheets, and after that you have printed the tutorial and again you are doing those same kind of workouts in the tutorial, then it will be established in your memory like concrete, right? So this is the way you have to do. Sir, is the video on? It's not visible. uh, I think I am visible, right? Is there a problem of the video? Others, please let me know. Is there any problem? Yeah, no, no, no. Right. It may be your kind of connection issue or something, right? Thanks, thanks. Okay, good. So let's move to the measuring instruments. Okay. So why we need measuring instruments? For what purpose we need measuring instruments? Measuring instruments. Measuring instruments, right? For what purpose we need measuring instruments? I will start the story like this. In the world, there are two type of things. They are qualities and quantities. Qualities and quantities. Have you heard about these two? Qualities and quantities. So what are qualities? What are qualities? For an example, uh, your mother loves you. Can you ask her, Amma, how much would you love me? What's the amount of your love? You can't ask, right? Because it's a quality. You say that guy is very kind. So can I ask, what's the amount of kindness he have? No, it's a quality. But if you say that he's a very big person, so I can ask that, what's the weight of him? Yeah, it's a quantity. The weight is a quantity, right? Weight is a quantity, while the love is a quality. So there are two kind of things we can perceive in we are living our day-to-day life, right? So out of these two parts, what will we take for the physics? Qualities or the quantities? Quantities. So specifically for physics, we call them as physical quantities. We call them as physical quantities. Mostly, I think that most of you have gone for any kind of physics classes before this, right? Because you are wish to write A levels on 2028. Almost the A level classes for 2028 A levels was started a few weeks before this. So I guess that most of you have gone for any kind of A level classes. In there, the first topic you have learned is the physical quantities. The ones who know the thing, right? Ones who have learned. Others don't worry, right? Others don't worry. The ones who have learned this before, can you please put onto your chat how many basic physical quantities are there in physics? How many basic physical quantities are there in physics? Just put into a chat the ones who know the answer. Right? Good. Good. How many basic physical quantities are there? Yeah, it's 7, right? 7. So the ones who haven't joined for any kind of classes, don't worry. Today we will cover the measuring instrument session, and I will take another kind of day to cover those parts, right? The introduction for the physics, introductions for the units and dimensions part, right? Others don't worry. For the today's session, any kind of previous things will not be affected. You can do the today session itself with the things that I am teaching to you. Right. So we came to a point that we need the quantities. So I erased the quantities part. For the quantities, also in the example, I said that his weight is 80 kilograms. So 80 kilograms is what? The measurement of his weight. So for the physical quantities, we have to measure them. Otherwise, it's useless. If we are expressing any kind of physical quantity, we have to express it with its value. To get the value, we have to measure it. To measure, we need measuring instruments. This is the introduction for measuring instruments. This is the reason why we need measuring instruments for the physics, for the stream of physics, right? So there's no physics without measuring instruments, because we can't build physics without quantities, without defining quantities and defining values for them. With the values, with the quantities, subjecting them all into the equations, we build up physics on top of that, right? So that's why we need measuring instruments. I will go to the tute. I will also raise your hand or put on the chat if you don't have the tute. I will again put it to the Zoom chat also. If anyone in here don't have the tute, right? Also, if you don't have the tute, just put a WhatsApp message to this number. This is my personal number, 074654311. Right? You can put just a WhatsApp message to this number, and I will send the tute. Raise your hand if you don't have the tute. Right? Nice. Yeah, everyone have the tute. It's good. Right? If you don't have the tute, you can put a WhatsApp message. Right? Right. I will go for the tute, and when I want to show some workouts on the tute, I will share the tute. Otherwise, I will go with the tute, and you also parallelly go with the tute. Okay, I will get my tute into my hand, right? The topic is measuring instruments. Clear. Now we know that why we need measuring instruments. To build physics, we always want to get measurements for the quantities. To get measurements, we need measuring instruments. Right. I will continue with the tute. To gain a quantitative understanding of physical phenomena, measurements are essential. The tools used for this purpose are called as measuring instruments. Fine. Every measuring instrument has a scale. Yeah, you need a scale. Otherwise, how you can read the value? You should have a scale in every kind of instrument to read the value, to get the magnitude of that physical quantity. Some instruments like meter ruler allow for direct readings. Others such as string balancers or analog clocks provide readings via an indicator moving along a scale, right? It's a very simple thing. Instruments like meter ruler like this, right? This is also a kind of meter ruler. There's a scale on this the edge of this meter ruler. So you can get the direct reading from the scale. And also there are some things like, if for an example, if you take a clock, a kind of pointer is moving in the scale. So by the pointer, we can get the reading. Simple. Next point. Errors occur in every measurement. Errors occur in every measurement, right? That is nice. Not nice. The point is very valuable. Errors occur in every measurement. So you can't get a measurement without an error. Always you have an error. The thing you can do is you can minimize the error, right? Errors occur in every measurement. In this section, we primarily discuss length measuring instruments, the errors associated with them, and how to minimize those errors to obtain successful measurements. Right? Length measuring instruments discussed. What are the things we are going to discuss here? Number one, meter ruler, you know, right? Number one, meter ruler. Number two, vernier caliper. What's mean by vernier caliper? This is the vernier caliper, right? We will learn about this later. This is the vernier caliper. Number three, micrometer screw gauge, another instrument. Mostly you haven't heard about these instruments in your levels, right? Number four, spirometer. Number five, traveling microscope. There are five main instruments which we use to measure the length will be discussed in this session. Not in this session, those are the main things in your syllabus as well, right? Under the measuring instruments part, the main instruments you have to learn is these five instruments. Also, in your practical book, if you get your practical handbook, you can download it from the from internet, from the official site of gov. Something I can't remember. There's a kind of site for the educational institute, right? The official site of the education for Sri Lanka. There you can go and download the practical handbook. In that practical handbook also, there are practicals based on these four instruments. They have eliminated the meter ruler for the practicals because meter ruler is a simple kind of instrument. For other four instruments, they have assigned practicals. So these five instruments are the main instruments you have to learn in your syllabus. So end of today's session, I guarantee that, right? End of today's session, I will guarantee you will be able to answer any kind of questions coming from these parts in the papers. If you are saying not, right, even though you have finished this seminar engaging with me very well, and you say that, and you claim that, so I can't write to these questions by the knowledge I gain from your seminar, I will stop the classes, right? So I guarantee that you will definitely able to answer any kind of questions comes from these measuring instruments part at the end of the today's seminar. right? For the tute, I have already put the previous exam paper questions, right? The previous exam paper questions from 19, I think, I guess it's 19, yes, 1995 to today, right? All the questions have put uh, into this tute. Also, you can try those questions after the seminar, right? We will also arrange another day to discuss the questions, right? You can try it and check whether your knowledge and check your knowledge, right? Check whether you have grabbed the part correctly. This is the way you want to learn any kind of subject, from any kind of teacher, right? If you learn something, some part from a teacher of any kind of subject, you have to test it with the past paper questions, right? If you have learned the thing and you can't do the past paper questions came with that part, that means you haven't learned it correctly. So you have to always check yourself, right? uh, like we say, uh, the scholarship exam is an exam of parents. O levels is an exam of teachers, and now you are in A levels. This is the exam of viewer. So you have to do, right? You have to do the work. I can only guide you. I can only show the path for the wisdom. You have to get the wisdom. You have to go to the wisdom, right? Okay. Right. Give me a few seconds. Let we will go for the next topic. This is the most important topic in this entire seminar, right? Even though up to you until you face the exam, for any kind of measuring instruments question, you will heard this word. What's the word? Least count. Least count, right? In short form, we call it as LC. So what's mean by LC? Least count is we can define least count like this: the minimum amount that can be measured from an instrument. The minimum amount that can be measured from an instrument, any kind of certain instrument. For an example, if we take the meter ruler, have you ever seen a meter ruler? I guess yes, for everyone. Every one of you should have definitely seen a meter ruler. Can you put into your chat? There are the scale is calibrated in meter ruler, right? Scale is calibrated, right? Can you please put onto the chat what's the distance between these two consecutive lines, calibrated lines? What's the distance between consecutive lines in the scale of meter ruler? Just put into the chat. Right. Yeah. One have put the NIE.lk, the website you can get the learning materials. Right. Put on your chat. What's the distance between two consecutive lines in a meter ruler? Just put. If you don't know, you can just take out your small meter ruler in your pocket, right, in your purse, and check. This is also a meter ruler. Nice. 1 millimeter. There are some answers as 0.1 millimeter also. What's the correct answer? 0.1 centimeter means 1 millimeter, right? Thank you. 1 millimeter. 1 millimeter. Good. Yeah, it's 1 millimeter. It's 1 millimeter. It's not 1 centimeter. Like, if you think about the meter ruler at once, you get like you remember that the meter ruler is for 1 meter there are 100 centimeters. So the meter ruler is calibrated by centimeter up to 100 centimeters. Yeah, it's right. Uh, Only the values are written in the centimeter lines, but if you zoom it and look, 1 centimeter in a meter ruler has divided into equal 10 parts. So the length between two consecutive lines in a meter ruler is 1 millimeter. 0 and 1 in centimeters, right? They have put the values on the lines in centimeters. That's correct. But there are lines to measure 1 millimeter. So it means that you can measure a 1 millimeter using meter ruler, right? Isn't it? Yeah. Why not? The distance between two consecutive lines is 1 millimeter. So you can measure 1 millimeter using a meter ruler, right? It's correct. So what's the least count of the meter ruler? We came up for a point that least count means the minimum amount that can be measured from an instrument. So what's the least count of the meter ruler? It's 1 millimeter, because the minimum amount you can measure from a meter ruler is 1 millimeter. As an example, I will mark these values in millimeters for the easiness, right? Right. This is a meter ruler scale, and this is a any kind of any middle place of the meter ruler. So here in millimeters, right? It's in millimeters. The calibrations are also in millimeters. So let's take this is 30, then 31, 32, 33, 34, 35. Like the calibrations are there, the values are there. So if we want to measure something like this, measure something like this, what's the measurement of this? What's the measurement of this? Can anyone put that into your chat? What's the reading of this or the length of this? Something in red. These are in millimeters, right? What's the reading here? Is it 32 or 33? Is it 33 or 32? Or 32 point something? Or 32 point something? Anyone can guess, like it's 32.2 millimeters. Fine, right? What's the correct value? The length of this rod or anything. Is it 32 millimeters, 33 millimeters, or 32.2 millimeters? 32 point, not the centimeters. Here I have put these values in millimeters, right? So keep all the values in millimeters. Then is it like 32.3? Can't measure you accurately using the meter ruler. The thing is the only instrument you have is the meter ruler. So you have to measure. You can't avoid. You have to measure. No any option. The only instrument you have is the meter ruler. Then you have to definitely you have to get the measurement. What's the reading? Yeah, here's the point. Up to now, we came up for a point like the least count of the meter ruler is 1 millimeter. The reason is the minimum amount which can be measured from the meter ruler is 1 millimeter. In your tute, I will go to your tute. The smallest value that can be measured accurately by an instrument is called its least count, 5. The smaller the least count, the higher the precision of the measurement. Yeah, higher the precision of the measurement. Fractional and percentage errors are minimized with the smaller least count. So there are two new words, fractional and percentage errors. Don't worry, we will go for those errors later in the later pages. I have put that part into under this part also to make this not comprehensive, right? So don't worry. So there was a nice point. The smaller the least count, the higher the precision of the measurement. Like if the least count of measurement of any instrument is smaller, we can get measurements very precisely from it. Like for an example, yeah, very good. One of you have told that we can't get the measurement of this correctly, right? Can't measure accurately using meter ruler because meter ruler can read 1 millimeter to 1 millimeter. You can't say values like 32.3 from a meter ruler because the least count of the meter ruler is 1 millimeter. You have to round off anything to the nearest 1 millimeter to record the reading which was taken from a meter ruler. If you want to go for a value like 32.3 millimeters, 2 millimeters, if you want to read a reading like this, what's the least count of that instrument should be? This is not a meter ruler, any kind of another instrument. There are such kind of instrument. This also a such kind of instrument. So in order to get this kind of measurement, what should be the least count of that instrument? Can anyone guess? Yeah, good. 0.1 millimeters. Because here you have measured this amount to the nearest 0.1 millimeter. Right? The nearest 0.1 millimeter. So then you can realize that if the least count is smaller, you can get measurements more precisely. You can get measurements more precisely. That's what I have put in this tube, right? You got the part. Example, the least count of a standard meter ruler is 1 millimeter, right? The distance between two consecutive scale lines. And also, if we go for the clock, which is in the next page, it shows that it's a kind of stopwatch. It's kind of stopwatch. It says that the time is 00, 13, 20, 148. This is the time reading of a certain stopwatch, right? Certain stopwatch. So, what is the least count of this stopwatch? What's the least count of this stopwatch? Normally, if we see a reading like this, these two digits are belong to hours. These two digits are belong to minutes. These two digits are belong to seconds. And these four, for what? milliseconds, right? Milliseconds. Because if this amount is raised up to 999 and another one, it goes for a second. So there are 1000 milliseconds for a second. Therefore, the last three digits are responsible for milliseconds. So what's the least count of this stopwatch? What's the least count of this stopwatch? 1 millisecond. Because you can measure the values using this stopwatch precisely to 1 millisecond, to 1 millisecond, right? You can't get values between milliseconds. You can get any value correct to the nearest millisecond. So the least count of this stopwatch is 1 millisecond, right? In the tube, it has said that the least count of this stopwatch is 1 millisecond. The method of determining the least count varies from one instrument to another. We will discuss this in detail later, right? Okay. Right. For the next topic, we will go for the next topic. So next part, recording measurements, right? Recording measurements. Now we are going to record the measurements which are taken from the instruments. Right. Okay. We'll go for the next part. How to record the measurements you have taken. Measurements must be recorded in a way that is consistent with the instrument's least count. You know the thing now. While looking at the reading, this is a recording of the reading. This is not the reading. This is the record. This is, I have got the reading and I have recorded in this whiteboard. And you are seeing the recording, right? So by looking at this recorded measurement, you can say that you said it. The least count of this of the instrument which is used to get this measurement is 0.1 millimeters. You told it in the chat. If you saw a measurement like 32 millimeters, it means that the instrument has a least count of 1 millimeter. So you have to record the measurement consistent with the least count of the instrument, right? Here, there are two readings like this, 32 millimeters and 32.0 millimeters, right? I will send you a poll. Please vote for this poll. The ones who think that these two readings are equal, these two measurements are equal, put yes. The ones who think that these two are different, put no. Quickly submit your answer to the poll. quickly. Select your answer and select submit. Okay. So here in the poll, I can't see your names, right? I can see only the poll. It's like the voting system. I can see who has voted. I can only see the vote. Therefore, don't be fear. Just vote your answer. Right here, I will end the poll. This is the results, right? You can see the results. 83% of you say that these two readings are equal. 17% of you are saying that these two readings are not equal. Right? Look the diversity. What's the correct answer? What's the correct answer? Yes and no. Right? In mathematical aspect, if you are doing mathematical operations like adding or multiplying or dividing any kind of thing, these two values are equal. 32 means 32.0. That's right. But if when you come to the measuring instruments part, when you come to the recording, when you come to record the values you have got from a measuring instrument, these two readings are completely different. These two readings are completely different. What's the different? I like if anyone can tell the difference by unmuting yourself. Can anyone tell the difference of these two readings? What's the difference?
The least common value of first one is 1 millimeter, but the second one is 0.1 millimeter.
Yeah, good. Yeah, that's the point. The least count of the instrument which used to get the first measurement is 1 millimeter. Right? Understand this clearly, right? Try to get this clearly. The least count of the measuring instrument which is taken to get this first reading is 1 millimeter. You know it. If we get that measurement, if you get this same measurement using an instrument which have a least count of 0.1 millimeters, sometimes the value may be 32.2 millimeters, right? 32.2 millimeters, because here the value is round off to the nearest 1 millimeter. If we get the same measurement, the same value using another instrument which has a least count of 0.1 millimeter, sometimes the thing may be like this, 32.2 millimeters. But in the second reading, it says that this is taken from an instrument which has a least count of 0.1 millimeters, and the value is 32.0. So now, if you compare these two values, you definitely tell that they are different. This is 32.2 and this is 32.0. Yeah. This is not a new value. This is the same value of this measurement, which is taken from an instrument which has a least count of 0.1 millimeters. Have you got the point? Therefore, these two measurements are entirely different, right? If you got the point, please put yes to the chat. Yes, yes, yes. Please put yes to the chat. Right, right, right. Good, good, good. Okay, that's the point. I will go to the tutor again. Measurements must be recorded in a way that is consistent with the instrument's least count. We know that. For an example, a meter ruler can be measured. Meter ruler can measure lengths with the precision of 1 millimeter. Therefore, measurements should be recorded to the nearest 1 millimeter. Right? there are few measurements. There are some records of the measurements given below that sentence. So we have to write something in front of them. So the ones who are writing the parts in separate papers, get those papers and write the topic as recording measurements, page 3, and you have to write this. Right? There are several readings. The first one is 56 millimeters. The second one is 56.0 millimeters. The third one is 56.3 millimeters. Right. The fourth one is 56.31 millimeters. We are going to write the difference between these two measurements, these two readings, these two recorded readings. Right. Let's write in front of 56 millimeters. Right here, in front of 56 millimeters. Right. This reading has taken from this reading has taken from this reading has taken from this reading has taken instrument with least count 1 millimeter. Then when you won't write least count, you can write it in short form LC. Right. This reading has taken from an instrument with least count 1 millimeter. Least count 1 millimeter. Least count 1 millimeter. Means have rounded off it to the nearest 1 millimeter. Have rounded off it to the nearest 1 millimeter. Have rounded off it to the nearest 1 millimeter. Means have rounded off it to the nearest 1 millimeter. To the same point under this 56 millimeters, write another sentence. Write another sentence here. If we get the measurement, if we get the reading to the nearest 0.1 millimeter, if we get the reading to the nearest 0.1 millimeter, if we get the reading to the nearest 0.1 millimeter, the value may be different. Value may be different. Right? Right in the second reading, in front of the second reading, 56.0 millimeters. Right? Right here, 56.0 millimeters. 56.0 millimeters. Right in front of this reading. This is taken precisely, this is taken precisely to the 0.1 millimeter. This is taken precisely to the 0.1 millimeter. This is taken precisely to the 0.1 millimeter using an instrument, using an instrument, using an instrument, using an instrument, using an instrument with the least count 0.1 millimeter. With the least count 0.1 millimeter. With the least count 0.1 millimeter. Next point. The same thing, right? The same thing. This has also taken from an instrument. This has also taken from an instrument, This has also taken from an instrument with the least count 0.1 millimeter. With the least count 0.1 millimeters. 0.1 millimeters. And got the value as 56.3. Got the value as 56.3. Got the value as 56.3. Here, this measurement is taken precisely. This measurement is taken precisely to the nearest 0.01 millimeter. This measurement is taken precisely to the nearest 0.01 millimeter. So nearest 0.01 millimeter. This measurement is taken precisely to the nearest 0.01 millimeter. Least count of the instrument should be 0.01 millimeters. Least count of the instrument should be 0.01 millimeters, right? Got it? Yeah, I guess all of you have understood the point. Okay, there's a question. Right? There's a question below this part. Read the question. Read the question. 5 measurements obtained for the thickness of a non-uniform plate. There's a non-uniform plate and we are measuring the thickness from 5 different places and the readings are recorded here. 2.11 millimeters, 2.12 millimeters, 2.14, 2.13, 2.12. I will write the readings. 2.11, 2.12, 2.14, 2.13, 2.12 millimeters. Is there a problem? Like there are 2 readings as 2.12 millimeters. Is it a problem? No, it's not a problem. We are just measuring the thickness from 5 different places, and out of 5, we have got the reading 2.12 millimeters in 2 places. That's it. There's no any issue there, right? These are the 5 readings for the thickness of that non-uniform sheet, right? Obtain an average value for the thickness of this plate. You have to obtain an average value. Very easy question. Even though you are doing scholarship exam, you can do this question. You have to get the average. So how to get the average of 5 numbers? It's very simple. Get the sum of 5 numbers and divide it by 5. Okay, let's do average thickness. Very simple question. Sometimes you may think that why sir is giving these kind of silly questions in our A-level tubes. Let's see. 2.11 plus 2.12 plus 2.14 plus 2.13 plus 2.12 over 5. So from here words, learn the art of writing answers, right? You know the thing you have to do is a very simple thing. You have to get the sum of all 5 numbers and divide it by 5. Sometimes you may write this in a separate sheet and get the sum, and average thickness equals that sum is divided by 5. Don't do it, because if we are allocating marks for this question, sometimes 1 mark will be allocated for this expression, right? 1 mark will be allocated for this expression. Like, you have to clearly mention that you are adding all 5 values here and dividing whole thing by 5. 1 mark will be allocated for this. If you do the addition in somewhere else and you get this paper and come your home, the marking panel should come to your home to get that paper and look that part, right? So you have to write those parts clearly in the paper answer sheet. After writing this, you can just write the answer if needed. But if I was you, I will do another step, like the addition of these 5 numbers will be reported here, and it will be divided by 5 again, and as the third step I will go for the answer. That's my way, right? So always try to uh, present your answer in a good manner to allocate marks, right? It will be easy to allocate marks for the marking panel, or the marking the one who marked your paper. Okay, add these 5 numbers. I will use the calculator to add, but you can't use it. 2.11 plus 2.12 plus 2.14 plus 2.13 plus 2.12. Right. The answer is not the final answer. It's 10.62. 10.62 should be divided by 5 again. I will divide this by 5. Nice. The answer is 2.124 millimeters, right? 2.124 millimeters. Hands up, who got the answer? Who have finished? No, you don't want to hands up. Just put done in the chat box if you have finished the workout of this. If you have finished writing the thing, just put done quickly. Finished. Done, 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 done. Right. Has everyone done? Okay. Get a red pen and mark as this answer is completely wrong. Right. Get a red pen and mark this, because if we want to memorize something very perfectly, this is a kind of best way to do it. You do the wrong way and you mark it as this is completely wrong. And now we are going to write the correct way in the red pen, right? Can anyone tell me what's the? Yeah. One has put that into the chat box. There should be 2 decimal places, right? That's totally correct, because we have learned that part, right? The few minutes before. By looking at these readings, you can tell that this is a reading which was get from a measuring instrument which has a least count of 0.01 millimeter, right? This is the thickness gained by that instrument. If we are reporting the thickness of that sheet which was got from that instrument, how you can express that in 3 decimal places? That's completely wrong. You have to again express the thickness, your final answer, in 2 decimal places. Otherwise, someone looks the report and see you have used the instrument of least count 0.01 and you have measured the thickness accurately to 3 decimal places. It's a miracle, right? You can't do miracles here. You have to follow the logics of physics, right? That's why I have put here the logic of physics. So the answer should be 2 point. You have to round off these two decimal places, 2 millimeters, right? Write the answer, write the correct answer, and write this sentence below the answer using red pen, right? Use the red pen to write this sentence. Write the correct answer using the red pen and write the explanation also using the red pen, right? The thickness readings were taken, the thickness readings were taken from an instrument with the least count 0.01 millimeter, with the least count 0.01 millimeter. Zero point zero 0.01 millimeters. So you have to report the final answer. You have to report the final answer for the average thickness. Final answer for the average thickness. Average thickness. Also to 2 decimal places. Also to 2 decimal places. Right? Also to 2 decimal places. Right? If this value was 2.125 or 6, this one should be 2.13, right? You know how to round off a value, right? It's a very simple thing. Completed, right? Got the part, got the point, I guess. You got the part. Okay. Let's move to another interesting part of this lesson. Errors in measurements, right? Errors in measurement. Let's go to the next part, that is errors in measurements. What are the errors in measurements? Right? The absolute or the real error of a measurement. So error means you have to reduce the reading from the real value, right? Then you can get the error. If the real value is 34 and the reading is 33, if you want to get the real error, you have to reduce your reading from the real value. Then it's 1 millimeter. This is the error, right? This should be the error. But the thing is, how you could know the real value? There is no way to know the real value, because to know the real value, again we want to get the measurement. Then there's an error in that measurement too. So in the world, we can't get the real values of anything. We can't get the real values of anything, because to get the value, we have to measure. When we are measuring, we do errors. Then it also has another error. So we can't follow this method, right? We can't follow this method. Means that we can't find the absolute error of any kind of measurement, because we don't know the true value. We don't know the real value. If you know the real value, it's a simple thing. You have to reduce your reading from the real value, then you will get the error. But the thing is, you can't, there is no any way to get the real value of the measurement. So we can't correctly get the absolute error. Therefore, we come to a point like this. The maximum possible error in a measurement is generally equal to the least count of the instrument. What does that mean? The maximum error that can be happen in measuring something is equal to the least count of the instrument. Is that true? Let's see. This is the mid ruler, right? I need your answers. These scale lines are marked in millimeters. Right here, 120, 121, 22, 23, 24, 125. These are millimeters, right? So 120 means 12 centimeter line. 125 means 12.5 centimeter line is here. These all values are marked in millimeters. If there is something to measure, and it will lie here. Please put into the chat, what's the reading of this measurement? What's the reading of this measurement? This is a meter ruler. Keep in your mind the least count is 1 millimeter. So what's the reading of this value? Put into your chat quickly. Just put the value you think. What's the reading of this value? Just put. Don't worry, even if your answer is wrong. Just put the value of this, the length of this rod, the reading here. 120.25, you can't get 25 because this is a mid ruler. You have to report the readings to the nearest 1 millimeter. To nearest 1 millimeter. That's a basic. So you have to follow that basic and give me the answer. What's the value of this, the length of this rod? 120.2. One answer came. It's 120.2. Few more answers. Right. Put in the everyone's chat. 122.5. You can't say 2.5 because the least count of the instrument is 1 millimeter. Right. Some can say the reading is 120.3. Some says the answer is 120.2. Some says the answer is 120.3. Right. Vote for these two numbers, A and B. Vote for these two numbers in the chat. What's the answer? A Some says A. Some says B. Good. Other ones. Tell one letter out of these two letters, A or B. B, A, B, A, B. Right. You all oscillated between the answers 120.2 or 120.3. Right? You all are in between these two answers. I can definitely say that 120.4 is wrong, right? I can definitely say that this one is wrong. Any one of you haven't said this answer. All of you have said 120.2 or the other answer 120.3. No one of you said this answer. Also, no one of you told this answer 120.1. Okay. So what's the maximum error can be happen? The maximum error of the reading should be equal to this amount, because all of you are in between 120 and 120.2 and 120.3, right? If the correct reading is 120.2, the ones who said the answer 120.3 has an error of sorry, 100, not 120.3. This is wrong. This is 122 and 123, right? Sorry, I got wrong. My fault. 120, 121, 122. This is 122 millimeters. This is 123 millimeters, right? No one of you had said that 124 millimeters. And no one of you said that this is 121 millimeters. All are in between these two answers, 122 and 123, right? So, if the correct reading is 122, the ones who said the answer is 123 has an error of 1 millimeter. If the correct answer is 123, the ones who said the answer is 122 has an error of 1 millimeter. So the maximum error can be happen is 1 millimeter, because you always read this the nearest millimeter, then you get the answer as 122 or 123. No one of you get these answers. So the maximum error can be happen is equal to the least count of the instrument. Got it? Got the point? Put to the chat if you got the point. Yes, put yes to the chat if you got the point. The maximum error can be happen when reading the thing is 1 millimeter here. Put yes to the chat. Good. Nice. That is the thing I have drafted in your note. The maximum possible error in a measurement is generally equal to the least count of the instrument, right? This is known as the absolute error, right? So we are defining absolute error like this, because we can't know the real value. If we know the real value, we can reduce the reading from the real value and get the absolute error, but it's we can't do it. So the maximum error can be happen when getting a reading is equal to the least count of the instrument. So we can call it as the maximum absolute error, right? This is the maximum error that can happen. It is good practice to report measurements with their errors, right? If we are reporting this measurement, it's good to write this as 122 plus or minus 1. Then it's clear, right? It may be 122 plus 1 or minus 1. 123 plus or minus 1, right? So it's good to report the measurement with its maximum error, means the least count. Then there's another interesting point. The effect of an error depends on the magnitude of the measurement. To represent this clearly, errors are expressed in two ways, as fractional error and the percentage error. These are also known as relative errors. The above one is absolute error, and now we are moving to relative errors. There are two types of relative errors, fractional error and percentage error. So here, the thing here is the effect of the error depends on the amount of the measurement, right? For an example, if I'm weighting, if I'm measuring my weight, right? Let's take it 65.5 kilograms. Right? If I do an error of 0.1 or 1 gram, 1 gram means 1 over 1000 of kilogram, right? It's not well affected to the reading because my reading is 65.5 kilograms, means in grams 65, 1, 2, 3, 500 grams. If there's an error of 1 gram here, this will be 65.501 grams, right? Again, if I convert this to kilograms, it's 65.501 kilograms means 65.5 kilograms. So if I do a error of 1 gram here, that doesn't make any sense, right? But think, if we are measuring a kind of medical kind of things to produce a drug, it's a medical drug, we are putting those kinds of in milligrams there, right? When preparing or producing any kind of drugs, we have to put them in very precisely in milligrams formats, right? Sometimes 0.01 milligrams should be added. So in that case, if I do error of 1 gram, what will happen? The one who used the medicine, the drug will die, definitely, right? Because 1 gram of error is affecting this reading in a different manner, and the same error affecting another very tiny reading in a totally different manner, right? So if we only say the error is here, it doesn't make much sense. To make it more explainable, we are using these two formats, fractional error and fractional error and the percentage error. For example, there are two readings as in your tube, A and B. A is 208 millimeters, which is taken from millimeters, so plus and minus 1 millimeter. You don't want to put millimeters here. And the reading B is 2 millimeters, and the error 1 millimeter, right? If you get the reading, if you have got the reading from the meter ruler, the error remains constant. It's 1 millimeter, right? So the fractional error means fractional error. Fractional error means the ratio of least count. Actually, not the least count. Here, the maximum error should be count. But we know the maximum error is the least count of the instrument. So we have to divide the least count over the measurement taken, right? For A, the fractional error is least count is 1 over measurement 208. Both are in millimeters, then it's fine. This is the fractional error of the reading A, right? For reading B, the fractional error is least count 1 over the measurement 2. right? These are the fractional errors of A and B. It really gives the ratio of the error to the reading, right? Ratio of the error to the reading. But we know that the error is equal to least count. So in the equation, we form it as least count divided by the measurement. 1 over 208, 1 over 2. This is the fractional error. The percentage error means you have to multiply this by 100%. So the percentage error means you have to divide least count by the measurement and multiply it by 100% to convert this to a percentage. If I do that, the percentage error here is over 100% is equal to, the answer is given, 0.48%. If I get the percentage error of this measurement, 100%, it's 50%. Now you can clearly see the effect of the error. Here, in this measurement, in the measurement A, the reading A has an error of 0.48%. There's an error of 0.48%. But in B, there's an error of 50%. That means you have to avoid this measurement. You can't take this measurement as a correct measurement because there's an error of 50%. Here it's fine. There's an error of 0.48%. It's okay, somewhat okay. So now you can clearly see that a same amount of error affects the readings differently according to the amount of the reading, amount of the measurement. To express that idea clearly, we are using two concepts, fractional error and the percentage error. Fractional error means the least count over measurement. Percentage error means the least count over measurement should be multiplied by 100% to convert it to a percentage. So then you can get a very good idea that what kind of error is there. If there's an error of 0.1% in a certain reading, we can come to a conclusion that it's a fairly good, it's good. No any issue. There's an error of 0.1%. If there's an error of 90%, you have to avoid it. You have to throw it away, right? That's the point I wanted to highlight here. I put to the chat that understood if you have got this point. Put to the chat as understood if you have got this point. Understood. 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 Good, 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 good. Right, good. This is completely available in your note. Measurement A and for measurement B, the fractional errors are here, 10208. If we simplify it, it nearly equals to 0.005. This is equal to 0.5. If we convert them to the percentage errors, the values are here. So then, by looking at these percentage errors, you can looking at these percentage of the fractional errors, you can get a big idea about the measurement. Can I use that measurement to, is it want to throw it away, right? Accordingly, the measurement A has a percentage error of 0.48%, while measurement B has a percentage error of 50%. Therefore, measurement A is more accurate. A measurement is considered, this is a very important and this is the most important point in errors, right? A measurement is considered acceptable only if its percentage error is less than 1%, right? A measurement is acceptable only its percentage error is less than 1%. Based on this, if the smallest length that can be measured using a meter ruler without exceeding 1% error, right? According to that result or that conclusion, we made that statement, right? According to that statement, it says that for an measurement to be acceptable, the percentage error should be less than 1%, right? It's fair. When you are using something from meter ruler, in order to keep the percentage error less than 1%, the minimum amount you want to measure, let's take it as X. So the percentage error means least count over the measurement, it's X into 100%. According to that statement, this percentage error should be less than equal to 1%, right? This, according to that statement, the percentage error should be less than or equal to 1% in order to be a certain measurement acceptable. Let's simplify. I will put X to here. Percentage marks will be cancelled, and 1 millimeter into 100 means 100 millimeters, means 10 centimeters, right? So X should be greater than or equal to 10, means that if you are getting a measurement from a meter ruler, the measurement should be greater than equal to 10 centimeters. Means the meter ruler is not suitable to measure the lengths less than 10 centimeters. If we measure the lengths which are less than 10 centimeters, definitely the percentage error will exceed 1% and the measurement will not be acceptable. Got the point? So for the meter ruler, the minimum, right? For the meter ruler, if the smallest length then can be measured using the meter ruler without exceeding 1% error is 10 centimeters. The workout is done in the tute. You don't want to do it again. So only lengths greater than 10 centimeters should be measured using meter ruler. It is not suitable for measuring lengths smaller than this. For such smaller measurements, an instrument with least count smaller than 1 millimeter should be used, right? It's fine. If we want to measure the lengths which are smaller than 10 centimeters, we have to use another instrument which the least count is less than 1 millimeter, right? From a instrument with the least count of 1 millimeter, this is the minimum amount of length can be measured without exceeding the 1% error. Got the point? You got the point, right? Good. For the next part, do you want a break? We started at 9 and it's 10:40. We will get a break at 11, right? We'll get a break at 11. Quickly, we will cover the errors part here. Right. Actually, about fractional error and the percentage error are the methods of representing errors in a more explainable way, right? It has a more meaningful way. Other than all the errors that can be happen in taking measurements can be divided into two parts. They are systematic errors and number two, random errors. Number one, systematic errors. Number two, random errors. Now we are going to looking at the errors in a different aspect, right? Systematic errors and random errors. So what does mean by systematic errors? Systematic errors. Systematic errors are the errors that arise due to faults in measuring instruments or in the experimental setup. Systematic errors occur due to the faults in the measuring instruments. For an example, in a meter ruler, they have wrongly calibrated the scale. That means the length between two consecutive lines should be 1 millimeter, but they have wrongly calibrated it. The length is not 1 millimeter, it is less than 1 millimeter. Then the every reading we are getting from this instrument will be wrong. It's a systematic error. Any error which related to the instrument, the fault instruments, or the fault setups we are going to take the measurements, all belong to the systematic errors, right? Even if the same measurement is repeated several times and the average is taken, right? Now you have an experience. You did a question, right? You did the question like taking the thickness of a sheet in five places and take the average. If you have a systematic error, like if you have a kind of any fault in your instrument, if you take the same measurement 5 times and divide it by 5, what it makes sense? There's no any sense, because every reading you are getting from that instrument is wrong. So even if same measurement is repeated several times and the average is taken, these errors cannot be eliminated. You can't eliminate these errors by repeating the measurement, right? Repeating the thing. However, in most cases, systematic errors can be corrected or minimized. Mostly the systematic errors can be corrected. There are two types of systematic errors: zero error and parallax error. So we will discuss about zero error later. We will go for the parallax error now. Parallax error. What does mean by parallax error? This is related to the fault apparatus, like fault setup. We are going to take measurements. For an example, you are going to read the height of this bottle, right? You have kept the meter ruler here. You have kept the meter ruler like this. To get the height of this bottle, you have to take the reading here, right? If this is R1, if this reading is R2, to get the height, you had reduced R2 from R1. It's obvious, right? You had reduced R2 from R1. But R2 is okay, you can get the measurement. But when you are going to get R1, the edge of the measurement doesn't touches the calibrated lines. Then if you see from this side, you think that the value is 35 millimeters. Not 35. Let's take 135 millimeters. If you look at this from the front side, you take this as like 134 millimeters. If you look at from this side, you better take this as like 132 millimeters. The reason? What's the reason? The reason is the edge of the measurement doesn't align with the scale. Here, there's no any issue because the edge is touched with the scale. You can get the reading correctly. Here, a parallax error happens. In the definition, it says that this occurs when the measured end does not align exactly with the scale markings. As a result, the reading changes depending on the point of the observer's eye, leading to a parallax error, right? For another example, you have seen the meter rulers with a kind of thickness. There are calibrated lines here, scale is here. You want to get this measurement. If you see it from here, the measurement is this. If you see this from this angle, the measurement will be this, right? If you see it from this angle, the measurement will be different. So the correct measurement is this one. These two measurements are wrong. The reason for happening this is the edge of the measurement has not aligned with the scale, has not touched the scale, right? You get different values from different angles. This is called the parallax error, right? There are some examples given in the tute. You can refer to them. And also to minimize them, you have seen there are some, even though your normal meat ruler, the edge is very thin. The edge has made to be very thin. Then, like, if the edge is very thin like this, then the scale lines touches the edge of the measurement, right? Then we can avoid that error. There are some examples are given in the pictures. And also to avoid this, you can place a set square here. Set up a set square. Then the edge is touched with or aligned with the scale lines. Then you can avoid the parallax error. So that's why I told that these side of systematic errors can be avoided. Right? You can completely avoid this error. You can avoid this error by using this kind of a mid rule. I think you got the point. This is called the parallax error. Then random errors, the other part. So if we remove all the systematic errors from a measurement, the errors still remain in the measurement are the random errors, right? Because there are only two types. If we eliminate one type, the rest, the remaining errors should be belong to the second type. It's random errors. After eliminating all systematic errors in the measurement, the remaining errors are random errors. The magnitude of these errors depends on the experience of the person taking the measurement, right? You know that. According to the experience, the measurement may be different. Like maximum error should be equals to the least count. That's true. But according to the experience and how you getting the error, this can be changed. And also this to minimize these random errors, what we have to do is we have to take the same measurement several times and get the average. If we get the same measurement several times and get the average, the error is also averaged and will be minimized. That's why we are getting a same kind of measurement 5 or 6 times and get the average to get a very precise value with minimum errors. You can reduce the errors of you can reduce the random errors by repeating the measurement, repeating the reading. Random errors cannot be completely eliminated. You can't eliminate these errors completely because for every reading there's definitely an error, right? There's definitely an error. However, they can be reduced by taking repeated readings of the same quantity and calculating the average value. The absolute error and relative error discussed above are associated with this type of error. Those two are also belong to the random errors. When measuring the thickness of a glass block, it is good to it's good practice to take measurements at several points, example about 6 positions, and calculate the average value. So always we are getting an average kind of thing to minimize the random errors, right? So for the summary of the errors, let's take a note. Once you have the printed copy of the tute, write in the tute. And once you are writing in papers, just put a topic as summary of errors. Here's the summary. Mainly, errors are two types. What are the two types? Systematic errors random errors. right? We discussed about one type of systematic error, and also we named another one, parallax error. The other one is zero error. We will discuss about the zero error later, right? Zero error is a very common error in measuring instruments in our questions. And random errors, absolute error also belong to this. And relative error, and within the relative error there are two parts, fractional error and percentage error. Draw this chart, draw this classification of errors as the summary of errors. If you have completed drawing the classification, put done to your chat box. Done. Others? Have everyone finished drawing this? What about others? Some of you have put done to the chat. The ones who have finished drawing this. Others? Done. Good. Okay, complete quickly. Right. I assume all have completed writing this, right? So again, I remember you that the reason that I am telling you to put done or yes or something to the chat is not to measure about you from my side. It's to engage you for the session. That will be really helpful to you, not for me. Because when you are putting responses to the chat means that you are engaging with this. And again, your inside will know that you are doing this kind of a important work here. And it tries to memorize all the facts, right? So for your help, for your good, that the reason why I am telling you to put some words on the chat, right? So please follow them. Try to engage with the session. Okay, good. We have completely finished the errors. And now we have to move for the measuring instrument. Really, now the measuring instruments are going to start, right? So don't worry, it's not a big deal. It's not a big deal. From now onwards, we are going to learn about the 5 instruments that we mentioned before: the mid ruler, vernier caliper, micrometer screw gauge, spirometer, traveling microscope. These are the 5 main instruments in your syllabus, which we are using to measure length, right? Right, that's the thing. So before going to that, we will take a small break, right? It's almost 2 hours. So let's get a break of 20 minutes, right? 20 minutes. Don't go, stay until I say. Let's get a break of 20 minutes and we will join this again 11:20. 11:20. And you don't want to quite Zoom, be in the Zoom. I also keep the Zoom. I stop the recording, but I will keep the Zoom and you can be in the Zoom and go anywhere and come again after 20 minutes. And also listen, some of you have asked me about the uh, normal class schedules of my class, Logic of Physics, right? We are starting uh, your English medium class, the lesson mechanics. The mechanics is we call it as normally the backbone of physics. Without mechanics, you can't learn physics further, because the fundamentals and the baseline of mechanics will help you to understand every lesson you have, light or either oscillations or waves or heat or properties of matter. So any kind of lesson, the fundamental is established by the lesson mechanics, unit mechanics. Mechanics is a kind of a large unit, right? We will do it for several months, one unit for several months. And also mechanics is the best lesson you can use to practice to solve problems, right? In A levels, you don't have questions to answer. So what the matter of that? If you don't have questions, what's the point of learning? No, you don't have questions to answer. You have problems to solve in the paper, right? You have problems to solve. If you have done 1,000 problems, the problem in the paper will be 1,001, right? You don't get the ones which you did earlier. So you have to practice this. You have to get the experience of solving problems. So I guide you correctly to the end for a result, not for a. I always tell you to target you for 100 marks, because if you target 100 marks, then you can get A. If you target for 75 marks, you cannot go for an A pass, right? Definitely you will end up with an BOC, not BOC, BOC, right? So you have to target 100 marks. So we are starting the plan to target that 100 marks from next Saturday, right? Next Saturday means not tomorrow, 11th Saturday. From 7 p.m. to 11 p.m. We will give a break, right? We will give a break of 20 minutes in this session. So it's kind of two-hour sessions, 7 to 9 and 9 to 11, right? Also, we will give a break inside those two sessions. From 11th Saturday onwards, we are going to start discussing mechanics for a new syllabus and starting 2028 A-level English medium physics classes. So you can join here. I will put all the details into the group as well. You can join the class. I will put all the details in the group and how you want to join and how about all the details, right? So in the class, you will be the tutorials. Every tutorial will be delivered to your home, right? This session also, this is the tute of measuring instruments, right? These are the kinds of tutes you will get. Since this is online and free seminar, I can't deliver this tute to your home. But in your real classes, I will deliver these tutes to your home. And you can go along with the tutes with the comprehensive note. And I always teach aligning with the past paper questions. So after learning any part of the lessons, you can evaluate yourself by doing questions. Not only you, I'm also doing many questions. But then you can realize that I got this okay or not, right? Otherwise, you can ask it again from me or anyone else, or something you can do, right? So that's my normal teaching way. I always give a comprehensive note to every theory parts, and also I follow the all past paper questions as well as new questions, right? Both. And you can evaluate yourself with that. That's the way I am teaching. And also for practical discussions in physics, the practical is kind of from your entire paper, 20 marks will be allocated for practicals. You can bring those 20 marks from your home when you are going to the paper. That's why I have written here in these tutes, gathering arangan lagun visa. You can bring these 20 marks from your home and teach you to bring those 20 marks. And that plan is starting from 11th Sunday, 7 p.m. to 11. And the ones who want to join, send me a message as 2028 EM, right? Send me a message as 2028 EM, right? Okay, any questions about this class you will ask from me. privately or in the group or anything. Okay, we will go for the interval. It's almost 11:07, so we will extend the interval for few minutes, and we will meet up again in 11:30, right? Okay, go for the interval and come again at 11:30. You don't want to quit from Zoom, right? Okay, go and come.